Welcome back, everyone. In this video, we're going to summarize what we have seen in terms of the periodic trends. The first periodic trend that we looked at was the effective nuclear charge. We saw here that it increases as we go from left to right, and it increases slightly as we go down a group of the periodic table. The reason for the increase from left to right is because we're increasing the number of protons without actually increasing the shielding that's occurring. As we go from left to right, the electrons that are added into the valence shell, which means that they're not shielding each other. So we're just effectively increasing the number of protons. Therefore, there's a drastic increase in the effective nuclear charge. There's also a slight increase in the effective nuclear charge as we go down a group from top to bottom. The reason for that is because as we increase the number of shells, the electrons that are being added into those shells are being put into larger, more diffuse shells, and they're not as effective at screening each other as in the smaller, more compact shells. Therefore, the effective nuclear charge increases, but only by a small amount. Atomic radius is the second periodic trend that we looked at. We saw here that our largest elements are those that are on the bottom left-hand corner, and that our smallest elements are on the top right-hand corner. In other words, atomic radius is going to decrease when we go from left to right, and it's going to increase as we go down. It decreases here due to the effective nuclear charge. As the effective nuclear charge gets larger, the electrons are held more tightly to the nucleus, and therefore the size of the element as a whole goes down. The reason for the increase in atomic radius as we go down a group is due to the increase in number of shells. Those layers, as we add them on, increases the overall size of the element, similar to when you put on multiple layers. The next trend is looking at ionization energy. Ionization energies increase from left to right and from bottom to top. The reason for the increase from left to right is because we are increasing the effective nuclear charge, and so therefore those electrons are held more tightly to the nucleus. The reason why we have low ionization energies on the bottom is because those electrons are farther away from the nucleus. There's a large N value, and therefore they're farther away, and they're easier to pull off. There's a lower attraction to them. Our next trend is looking at electron affinity. And we saw here that the trend isn't quite as good for electron affinity versus the other periodic trends. However, if we take the absolute value of electron affinity, then the magnitude of electron affinity, that generally speaking, it increases as we go up a group and we go from left to right across the periodic table. Our last trend is for ionic radius. The ionic radius is going to increase as we go down a group, and it decreases as we go from left to right on the periodic table. So you'll notice that the ionic radius trend is the same as the atomic radius trend, and it's for the same reason. It's because our effective nuclear charge gets larger from left to right. Therefore, those ions are smaller. And the reason why it gets larger as we go from top to bottom is because we have an increased number of shells, and therefore those electrons are held out in larger shells and farther away from the nucleus. So to summarize what we've seen here, we talked about how the number of protons as well as the quantum numbers n and l affect the periodic trends. The proton number comes into play when we look at the effective nuclear charge. The principal quantum number we saw came into play a lot when looking at the number of shells that we have. And our L quantum number, while less significant, does play an important role when looking at the exceptions within the periodic trends. So when you take a look at the details of ionization energy, for example, we saw that The shift from the S block to the P block had a shift in overall stability and ionization energy. And that's because we're going from a lower to a higher energy subshell. That's it to summarize our periodic trends. Thanks for watching and have a great day.